Welcome to Fact Pulse, where we bridge the gap between science fiction and science fact. Today, we're delving into a tantalizing concept. What if we could travel through time? Imagine the possibilities that would open up. The ability to witness historical events firsthand, to see the world as it was centuries ago, or to leap forward and glimpse the future. The concept of time travel has always sparked our imagination and curiosity. Imagine stepping into a machine and visiting the dinosaurs. You could walk among these magnificent creatures, observe their behavior, and understand their world in a way that no fossil or scientific study could ever reveal. The past would no longer be a distant, unreachable place, but a tangible reality. Or meeting your future self, what advice would they give you? What successes or failures would they share? The opportunity to learn from your future experiences could change the course of your life. It's a tantalizing thought, isn't it? Time travel has fascinated people for centuries. From ancient myths to modern science fiction, the idea of moving through time has been a constant source of wonder and speculation. It's a theme that has been explored in countless stories, each offering a unique perspective on the possibilities and paradoxes of time travel. It's a popular theme in science fiction books and movies. From H.G. Wells' The Time Machine to the Back to the Future series, these stories captivate us with their imaginative scenarios and thought-provoking questions. They challenge our understanding of time and inspire us to dream about what might be possible. But is time travel really possible? Scientists have been grappling with this question for years. Theories in physics, such as Einstein's theory of relativity, suggest that time travel might not be entirely out of the realm of possibility. However, the practical challenges are immense. Can we actually journey through time? The idea of building a time machine is still far from reality, but the pursuit of this dream continues to drive scientific inquiry and innovation. Each discovery brings us a step closer to understanding the true nature of time. The idea of time travel is full of mystery and excitement. It challenges our perceptions and pushes the boundaries of what we believe is possible. The very thought of bending time to our will is enough to ignite the imagination and fuel endless speculation. It makes us question the very fabric of our universe. What is time, really? Is it a linear progression, or could it be more fluid and malleable than we ever imagined? These questions drive scientists to explore the deepest mysteries of the cosmos. We experience time as a constant flow, always moving forward. But what if this flow could be altered? What if we could pause, rewind, or fast forward through the moments of our lives? The implications of such control are profound and far-reaching. But what if we could manipulate this flow? The ability to control time would revolutionize our understanding of the universe and our place within it. It would open up new possibilities for exploration, discovery, and even personal growth. What if we could go back to correct a mistake or see what the future holds? The power to change our past or predict our future could transform our lives in unimaginable ways. It's a dream that continues to captivate our hearts and minds. While we haven't quite figured out how to build a time machine yet, some incredible scientific discoveries give us a glimmer of hope. Advances in quantum mechanics, wormholes, and the study of black holes are pushing the boundaries of our understanding and bringing us closer to the possibility of time travel. Let's explore the mind-boggling world of time travel and see what the future might hold for this extraordinary concept. The journey through time is not just a flight of fancy. It's a quest that could redefine our understanding of reality itself. Join us as we delve into the mysteries and marvels of time travel, and imagine what wonders await us in the realms of the past and the future. Albert Einstein, a brilliant physicist, gave us a revolutionary idea about time. His insights have fundamentally changed our understanding of the universe and our place within it. Before Einstein, time was considered a constant, an unchanging backdrop to the events of the world. But Einstein's theory of relativity shattered this notion, revealing that time is much more fluid and dynamic than we ever imagined. His theory of relativity tells us that time is not absolute. Instead, it is intertwined with the fabric of space itself, creating what we now call space-time. This means that time can stretch and compress, depending on various factors such as gravity and velocity. It's not the same for everyone everywhere. For instance, time moves slightly faster at higher altitudes compared to sea level because of the difference in gravitational pull. This phenomenon, though imperceptible in our daily lives, has profound implications for our understanding of the universe. Time is relative, meaning it can be affected by gravity and speed. Imagine two identical clocks. One clock stays on Earth, and the other travels into space at incredibly high speed. This thought experiment, known as the twin paradox, illustrates the concept of time dilation. One clock stays on Earth, and the other travels into space at incredibly high speed. As the spaceship accelerates, the clock on board experiences time differently compared to the clock on Earth. This difference becomes more pronounced the faster the spaceship travels. When the space-traveling clock returns to Earth, it will show a slightly different time than the clock that stayed on Earth. This is because the faster-moving clock has experienced less time due to its high velocity. This effect, though minuscule at everyday speeds, becomes significant at speeds approaching the speed of light. The faster-moving clock will have experienced slightly less time. This phenomenon is not just theoretical, it has been confirmed by experiments involving precise atomic clocks on airplanes and satellites. This mind-bending phenomenon is called time dilation. It means that time actually slows down for objects moving at very high speeds. The implications of this are vast, affecting everything from GPS satellites to our understanding of the universe's age and structure. It means time actually slows down for objects moving at very high speeds. For example, astronauts on the International Space Station experience time slightly slower than people on Earth due to their high orbital speed. While the time difference is tiny at everyday speeds, it becomes more significant as we approach the speed of light. This has led scientists to speculate about the possibilities of time travel and the nature of the universe itself. Einstein's theory of relativity opened up a whole new way of thinking about time, suggesting that time travel might not be entirely impossible. It challenges our perceptions and invites us to explore the mysteries of the cosmos with a fresh perspective. The universe is a vast and complex place filled with mysteries that boggle the mind and challenge our understanding of reality. From the smallest particles to the largest galaxies, the cosmos is a tapestry woven with intricate threads of space and time. Could there be shortcuts or tunnels that connect different points in space-time? These hypothetical passages, known as wormholes, have fascinated scientists and science fiction enthusiasts alike for decades. Some scientists believe that wormholes might be these cosmic shortcuts, offering a way to traverse vast distances in the blink of an eye. The concept of wormholes stems from the equations of general relativity, proposed by Albert Einstein. Imagine a piece of paper representing the fabric of spacetime. This simple analogy helps us visualize the complex idea of a wormhole. Now fold the paper in half so that two distant points touch. This folding represents the warping of spacetime, bringing two far-apart locations into close proximity. If you could create a hole through the paper, you'd have a shortcut between those 2 points. This hole is analogous to a wormhole, a tunnel through the fabric of spacetime. That's the basic idea behind a wormhole. However, the reality of creating or finding such a passage is far more complex and remains purely theoretical at this point. Another mind-boggling concept related to time travel is quantum entanglement. This phenomenon, rooted in the principles of quantum mechanics, challenges our conventional understanding of how particles interact. This strange phenomenon occurs when two tiny particles become linked in such a way that the state of one particle instantly influences the state of the other, no matter the distance between them. Even when separated by vast distances, these particles remain connected, and their fates intertwined. This connection is so profound that a change in one particle's state will instantaneously affect the other, defying the limits of classical physics. Imagine flipping two coins that are linked. In the world of quantum entanglement, if one coin lands on heads, you instantly know the other will land on tails no matter how far apart they are. This instantaneous connection between entangled particles suggests that information can be shared across vast distances in no time at all, a concept that has profound implications for our understanding of the universe. While still in the realm of theoretical physics, wormholes and quantum entanglement offer intriguing possibilities for time travel. If we could harness these phenomena, we might be able to bend the rules of space and time, opening doors to the past and future. The idea of bending space-time and creating shortcuts through the cosmos is not just a flight of fancy, it represents the cutting edge of scientific inquiry, pushing the boundaries of what we know and what we can imagine. As we continue to explore these concepts, who knows what incredible discoveries await us in the vast expanse of the universe. Time travel raises many fascinating questions and paradoxes. One of the most famous is the grandfather paradox. Imagine you could travel back in time and meet your grandfather before your parent was born. What if you accidentally prevented your grandparents from meeting? If they never met, your parent wouldn't be born, and neither would you. And if you weren't born, you couldn't have traveled back in time to prevent their meeting in the first place. This paradox highlights the potential contradictions and logical inconsistencies that can arise when we think about changing the past. Paradoxes like this make us wonder about the nature of cause and effect in a universe where time travel is possible. Some theories suggest that changing the past might create alternate timelines or parallel universes, preventing such paradoxes. Building a time machine is, well, complicated. While Einstein's theories and concepts like wormholes give us a theoretical framework, we're still a long way from having the technology to manipulate space-time in such a way. One of the biggest challenges is the sheer amount of energy required to create wormholes or achieve speeds close to the speed of light. We're talking about energy levels far beyond anything we can currently generate. However, scientists are constantly pushing the boundaries of our understanding. Experiments in particle accelerators like the Large Hadron Collider allow us to study the fundamental building blocks of the universe and explore the nature of time and space. While we haven't cracked the code of time travel yet, ongoing research and technological advancements might hold the key to unlocking this incredible possibility in the future.